Well, welcome to the first episode of my Repugnance series on the fear and repugnance of organic chemistry. This video series began when I was taking a 1-hour elective video for the internet. And each of us in the class at CCSF here in California had to do a storyboard, film, edit, and post a video blog to YouTube. So why not do something that's meaningful to help myself and others with some of my other studies and so forth. This is my first time, so please be gentle. And yes, I know you can see a lot of the video production equipment here. I don't know how it's going to turn out, but I got to get it in tonight. So what we see is what we get, and then I'll be doing some editing. I went crazy and I bought a lot of lighting, professional lighting, audio recorder, the H4n, and the accessories, and some accessories. And I also discovered that I had 3 cell phones, and as well as 3 cameras. So I'm editing film with 6 different camera angles and focus types. There will be numerous series of these vlogs that I'm going to be creating, time permitting, and you understand why when you realize they're ranging from medical school subjects, healthcare, physics, salsa, dance, fashion, biology, math, biomedical engineering, technology, IT, information systems, CAD, inorganic and organic chemistry, video production, networking, programming, web development, game programming, business, writing novels, writing poetry, and screenplays, English, Mandarin, French, and Swedish language, great thinkers, philosophy, religion, leaders, generations, and even sex. So, my name is Albert Sheppard, and I live in the San Francisco Bay Area near the Pacific Ocean. No, I'm not a professor, not an instructor, not a teacher's aide, and not a top grade earning student in chemistry, for sure. Note, yes, I know I broke all the rules in making this brief PowerPoint, which I will show you at a different time and edit it into the film. First, let me go to the chemistry section of my bookshelf here in my apartment. And don't be amazed. Look at all of the chemistry books that I have. I even have triplicates of some and duplicates of others. This is your general chemistry and organic chemistry section here, including chemistry for dummies. And we have down here at the beginning, starting right about here, organic chemistry. And that goes all the way down into here. No student in their right mind buys this many books. First of all, they're too expensive. They cost, at this level, organic chemistry, for instance, will run you anywhere from even used $190 all the way up to $250 to $275 per book. And then they'll probably add on that you need a lab book, not the notebook, a lab reference book, and that can run as much as $150, $200. And then they'll also generally want you to have a lab notebook, which is anywhere from $20 to $40. And sometimes even more. Let me grab a few of these and bring them back to the desk. The ones that I'm going to be using pretty much mostly during this series. But I actually use all of these reference books. When you're trying to solve problems, you have to look everywhere, including on the internet. Now, these are the texts that are primarily used at CCSF, San Francisco Community College. And don't thumb your nose at community colleges. Even students from San Francisco State and UC Berkeley get their chemistry at Berkeley City Community College or community college like, for instance, City College in San Francisco or Merritt and Skyline or let's see what's the other one, Laney. So there are lots of community colleges in the Bay Area, and they are just as tough, if not tougher, than some of your top 10 schools. How do I know that? Because I see a lot of the same exams and the same problems and discussions on the internet that we have. So there's nothing slacking. Now, this one's a solutions manual for the Wade textbook. And you're allowed to have that. Because if you don't understand the problem, it's not going to help you anyway just because you used it to do your homework. Now, some classes, some instructors will give you credit for homework, others won't, because they know that the solutions manuals are out there, and so why should they give you credit? Others give you credit to encourage you to do the homework, but it's generally something like either 5 or 10% of your overall grade, or else it's only 30 points for the entire semester on a 1,000-point scale for your final grade. Here's one called Laboratory Techniques in Organic Chemistry. At Berkeley City College, their lab reference book is that thick. And believe me, there's a lot of stuff in it. Here's the actual text for the class at San Francisco City College. City College of San Francisco. And let's take a quick look in through here. Lots of reference materials as you go through. Introduction and review. Get you down to page 36. And the introduction and review basically goes back to general inorganic chemistry. All the important things that you will need to know, which is pretty much everything, but primarily certain things that will be necessary for the organic chemistry student to understand before while they're beginning. It's based on it. The structure you have to be sure you understand before you go too far into organic chemistry. Then it gets into structure and properties of organic molecules. Over here we're talking about more structure and stereochemistry. Stereochemistry, big word that you're going to need to know. Study of chemical reactions, of course. But it's going to be different here because you're dealing with different kinds of chemical reactions than you may be used to. We all know that we've got a lot of elements on the chemical periodic chart, but there's about 103 of them discovered right now, and some of them are temporary elements where they've been manufactured or produced in the lab, but they don't exist very long in reality. But this chart says we've got 103 of them. The thing about organic chemistry, as you will learn, we don't have to deal with all these. Organic chemistry is pretty much down to carbon-related molecules. And there are a few essential other elements, very few, that are basically associated with these organic chemicals. We'll get into that later. One of the simplest ones is methane. I'm going to show a video here in just a little at the end of this, and there'll be a brief introduction about organic chemistry, what it is, and so forth. I have a ton of videos, as you could see from my shelves, and I'll show some of these shelves up close a little bit later on. But none of the videos are very helpful, both in inorganic chemistry and organic chemistry. But none of them totally prepares you for an exam or quiz. They're helpful. So you will have to dig into your text, and you will need to do the homework, and you will need to try to review and get answers to things you don't know before the exams. Organic chemistry is a bear. But don't fear. Don't be repugnant about it. Don't be repulsed by it. I'm going to show you in this series how to master it, even though you may feel like you're having some learning disability issues. It's a lot of stuff, but that's 2 semesters worth. Now, what else do I have here to show you? Let me show you this. You're going to need safety glasses, and I have a third pair, which I don't have with me right now, which is even smaller, kind of goggle types, and I like those the best. But these work pretty good too, and I also really like these. They're comfortable. Your face is not all enclosed by all this. And these are nice and comfortable too. There are some out there that are hard and that hurt your face, but this is nice and soft. And I think I paid about $20 for these at Skyline Community College. You will need to do labs. Some instructors want you to turn in the report. I got 9 of 10 on these. They don't give a heck of a lot of points on each one, but they're especially important. If you've been in chemistry, you know, because you have to be prepared to learn how to write conclusions, answer questions, make decisions, and above all, record accurate data. So this is a piece of cake. You should be able to get some of your best grades on labs because there's no mystery there. And you can research the information before you turn your lab report in and just do it the way the instructor wants, turn it in the way the instructor wants, and you already got maximum or near maximum points. A lot of people have a little trouble with it first, getting used to what that particular instructor requires. They all have little idiosyncrasies in terms of what they think is wrong and so forth. Most of that you'll pick up in general chemistry, inorganic chemistry, and you'll master a lot of those initial problems that students have in doing a correct lab report and writing your units and making sure you did this and significant places and all that. Organic chemistry is not all that, psychotic. You don't have the same problems as you would have in general chemistry. So we have a typical lab notebook here, which those pages were torn out of after they were completed. Another lab notebook. There's plenty of different types of lab notebooks, but they're pretty well standard layout because you have to have the title and all of that in there, and name of the experiment page. Pretty well documents what you're doing page by page. You will probably also be asked to buy a modeling set or have access to a modeling set. See how simple it is? Look complicated? It's not. Nothing but carbons here with hydrogen atoms. Amazing. Good part of the world, and you and your bodies and animals and plants are all organic chemicals. So I've got my little shoebox here full of modeling stuff. I always go overboard, so this is far more than you could ever possibly need in a class. But they really help for you to understand the stereochemistry, the structure, and how the molecules are laid out. You can't do it easily with paper. There are some Um, there are some techniques for doing it on paper to show the direction that the bond and the molecule are pointing out. For instance, here's a lot of the type of questions, and it may look complicated, but it's not. I got 4 points on that and 4 points on that, and that's exactly 4 points in that, and that's what they gave. Now I'd like to get your attention for just a minute. Imagine that each one of these points on this drawing, the bends in these lines, is a carbon atom. It's understood to be there, not drawn in at the bend or the junction of the lines. So by counting the number of carbon molecules, carbon atoms, I can begin to know what that molecule is and what its name is. The prefix, like penta, hexa, hepta, octa, nona, deca, etc., are commonly used words in English and other languages, standing for 5, 6, 7, 8, 9, 10, etc. So I already can begin to name the organic molecule by simply counting the carbon atoms. And we'll talk about it. If I taped over the questions, probably because I got it wrong or didn't get my full points, and they're questions that I'm going to have to relearn. And if you don't go over your quizzes and exams, then and make corrections and learn what it is you missed, then you've lost the advantage, because a quiz will turn into an exam, and an exam, of course, will turn into midterms and or finals. I like to do my homework on this kind of paper, and I like it when the instructor, most of them don't actually grade it. They just want to see if you did it. And I like it when the instructor actually gives some points, because I need all the points I can get in these in chemistry, and especially in organic chemistry. So, textbook, lab stuff, lab reference books, your lab notebook, the reports to be turned in. Some give credit for homework. Solutions guides, wonderful things. And you may even need some colored pencils. Again, I go overboard. 3 or 4 different colored pencils to help you when you're drawing things, especially as you get into mechanisms and so forth, showing where the electrons go, and to highlight stuff for your own benefit. Differences between general chemistry or inorganic chemistry and organic. There are lots of courses in the schools that are just considered general chemistry. If you're going on to higher education in medicine and so forth, or a lot of the higher health fields, you're going to need specifically the course called inorganic. But your catalog and your school will tell you which one you need that's okay for transfer. So inorganic chemistry is a killer for people like me. It really takes an extreme sustained focus for each problem, and for homework, and for I can't even explain it properly. It just drains the brain. Because it's not memorization. You can't memorize it. You're not going to get hardly any points for definitions or anything like that. Forget about it. This is science. You have to be able to analyze and do a thing called stoichiometric reasoning and calculations. And it just boggles the mind. As you learn it, you look back on it, and it was easy. But not while you're learning it. For most of us, it's mind-boggling. Now, organic chemistry is unlike that. They're not all psycho about statistics and statistics and calculations and Definitely not definitions and or stoichiometry. It's wonderful, a wonderful release and relaxation from inorganic chemistry. Hopefully you took a little break, get your brain cells back in order. But organic chemistry is just that. It's about the organism, how it functions and mechanisms. I'm going to talk on, you'll pick up a little bit more when I show this few minutes of a video at the end. But it's a big difference. There's a high dropout rate in chemistry. I saw people in inorganic chemistry where a class would start overcrowded and everybody couldn't get in, and before you know it, it was down to like 20, 30, and then at the end maybe 15 people in a class. 70% dropout. If you went to school a long, long time ago, forget about it. You don't know chemistry. They've just added so much more that you have to know, and you have to be able to mentally figure out and focus and be able to. You need to be a professional when you finish it. You can go out and do things in industry when you finish it. It's not general at all. So you need to take it very, very seriously, even if it's just simply a prerequisite. You won't get to your goal if you don't, first of all, master chemistry. And then I've seen these people drop out, so their futures change. I've seen people who thought they were going to be this or that. Now they have to choose another profession in life. And their dreams change. And of course, the fact that they didn't get into their particular dream that they felt good about and wanted to make a difference, then the world changes. The world changes because we lost these people, because somehow they got screened out inappropriately because they couldn't get through maybe one course in chemistry or inorganic chemistry or whatever. When in fact, everybody's different. They might have had a different learning method. The schools don't take time to work with you. Yeah, they've got office hours, if you're lucky. And they may even have some student teacher assistants. And there's all kinds of resources out there, but some people need a little extra help and a little extra push. But millions of millions do master it and make it. But for most of us, we really need to be totally clear out our life. Focus, focus, focus. Study, study, study all the time during these courses, these particular courses. And as I said, my problem is the inability to sustain focus. But, and if I didn't say that, now you know it. In spite of what I consider what is considered a valid focusing impediment, I graduated in 2008 from DeVry University with a Bachelor of Science in Technology, Technology Management, Bachelor of Science in Technology Management with the biomedical engineering concentration. And then I graduated from DeVry's, they own Keller Graduate Schools of Management in 2012. And I graduated in 2012 with 3 master's degrees, which I earned simultaneously. And now, with distinction, by the way, of a valid focusing impediment. And I have passed a very rough 2 semesters of inorganic chemistry that nearly killed me and made me crazy. Now I just have to complete 2 semesters of organic chemistry, 1 course in physics, and 2 semesters of biology to get accepted into medical school, and Ross Medical School, which is also a DeVry operation. Ross Medical School is where I'll probably decide to go. Now, before we go, I want to say I'm not doing this video series for the real bright students who had a great and lucky start with supportive and motivated parents, teachers, and friends who came to class with advanced preparation and a nice head of steam. Love you to death. More power to you. And I hope you realize that a lot of us, we need a little extra motivation and to help to find our way through the maze. As you probably realize if you took general chemistry, it's not about how smart you are. You cannot pass inorganic chemistry just because you're smart. Being really good at math helps, but it won't get you through. Chemistry has its own rules, and I've seen a lot of smart people go down the tube. Really, intelligence is not going to get you through, neither in inorganic chemistry nor organic chemistry. You have to learn the rules of how to learn it. Now, one thing is don't get behind and don't stress. There's just too much work and it goes too fast. They're pushing you through like there was no tomorrow. You cannot get behind. It's too much you have to learn. And this does not apply to other courses I've taken and all those other masters I've taken and my undergraduate degree and electives I've taken all over the different places in the country and so forth, and jobs and business. And I have never seen anything like it. You cannot get behind. You must stay up with it. If you can, get way ahead before you even take the class. Then focus. Review, simplify, study, all the time. Easy for me to say. I'm talking to myself, basically. I hope that by being able to explain this stuff to you, that I will force myself to learn it better. But we'll see.
An introduction to organic chemistry. In this unit, we're going to talk about several topics that are necessary in order for us to be able to understand organic. Some of these topics are things you've covered before, but a couple of them might be new. Let's begin with what organic is all about. It's all about patterns and processes. The patterns are those patterns that involve such things as physical properties and nomenclature or naming of compounds. The processes are the electron pushing and pulling that characterize the way in which many organic reactions occur. And if you can understand or grasp these patterns and processes, then you don't have to do so much memorizing in organic chemistry. It makes it much more understandable. Take 3 carbons at 4 bonds each. 6 hydrogen atoms, each of which can have 1 bond, and 1 oxygen atom. Remember that oxygen is limited to 2 bonds. How many different compounds can you make out of these atoms? Well, here's one that I came up with, and notice that each carbon has 4 bonds, each hydrogen has 1, and oxygen has 2. Here's yet another compound. And another. And isn't this one quite different indeed? And another compound. All of these are different. As we look at these 4 compounds, we can begin to have a concept of what the organic problem is. How do we organize these compounds that all have the same fundamental formula? How do we name them? How are their properties, chemical and physical, both similar and different? How do their reactions compare? And so much more. Well, this is a ketone. This is called an aldehyde. This is a cyclic alcohol. And this is an unsaturated ether. These are only 4 of the many different classifications of organic compounds that we will study. They are all very different. However, they have some important common points that you must remember. Each carbon has 4 bonds. Each hydrogen has 1 and only 1 bond. Each oxygen has 2 bonds, And as we use other elements, we will note the numbers of bonds that they may have. Their geometries and their hybridizations, their structures, their shapes are different. Maybe that is where we should begin.